Hello everyone, welcome to the Be Commended podcast on the history of magnetic resonance imaging, in short MRI. We, Roberto Paolella and Dennis Thomas, are two early stage researchers of the Be Commended project. In this educational audio, we shall take you through the history of MRI right from its invention to the current advances in the field. So, sit back and enjoy!
MRI is a powerful diagnostic tool in the clinic. If you have a neurological symptom that warrants further investigation, more often than not, you will be sent for an MRI scan. MRI provides excellent soft tissue contrast. In management of most of the diseases of the brain, MRI is the first line of investigation. Current advances in MRI are very promising for further empowering this imaging technique for high precision diagnosis. But MRI has been around only for the last 4 decades. How did the technique evolve so fast? And who were the brilliant minds responsible for this game changing invention? Let's try to find out.
MRI scanners have been around only for a while, but the concept of MRI are based on the field of nuclear magnetic resonance, which had been researched since 1938. NMR is a physical phenomenon in which nuclei in a strong constant magnetic field are perturbed by a weak oscillating magnetic field and respond by producing an electromagnetic signal with a certain frequency. NMR was first described and measured on molecular beams by Isidor Rabi. In 1946, Felix Bloch and Edward Mills Purcell expanded the technique for use on liquid and solids, for which they shared the Nobel Prize in Physics in 1952.
Raymond Damadian was an American medical practitioner and researcher. His early work on NMR concerned investigating potassium ions inside cells. He and a few other researchers independently investigated the signals of proton NMR in cells and found that the relaxation times were much shorter than in distilled water. Damadian, in 1971, predicted that cancerous cells would have longer relaxation times, both because of the disordering of malignant cells and because of their elevated potassium levels. He suggested that these differences could be used to detect cancer in the early stages where it would be most treatable, though later research would find that these differences, while real, are too variable for diagnostic purposes. In 1974, he received the first patent in the field of MRI when he patented the concept of NMR for detecting cancer after filing an application in 1972. However, it did not describe a method for generating pictures from such a scan or precisely how such a scan might be done.
In 1973, in a seminal piece of work, Paul Luterberg developed a method to produce images of structure non-invasively using NMR and published it in Nature. He developed a technique to image and distinguish two tubes filled with distilled water and heavy water using NMR. This had not been achieved before. This paved the way to the technique of MRI imaging as we know it today. Sir Peter Mansfield is credited with inventing slice selection for MRI and understanding how the radio signal from MRI can be mathematically analyzed, making interpretation of the signal into a useful image a possibility. When applying a gradient magnetic field to camphor between plastic, Mansfield was able to measure the nuclear magnetic resonance spectrum. Using Fourier transform, he found these values could be reconstructed into an image. In 1977, Mansfield saw the first cross-sectional MRI image of a student's finger using a small-scale machine. This opened doors to founding, allowing them to build a full-size machine.
In 2003, the Nobel Prize for Medicine was awarded to Paul Luterberg and Sir Peter Mansfield for their contributions to the development of MRI. Though the Nobel Prize can in principle be awarded to 3 scientists, Raymond Damadian was not selected for the award. This led to a controversy in the scientific community for not recognizing Damadian's contribution to the foundation established on the medical use of the technique. Some scientists claimed that Damadian's contributions, though noteworthy, were not crucial to the development of the technique. Paul Lauterberg's seminal paper in Nature, on the other hand, was the first clear description of using spatially varying gradients to produce images of objects. Sir Peter Mansfield neatly outlined the theory involved in the technique using the gradients and also developed the widely used EPI technique. Hence, they argued that only Paul Lauterberg and Sir Peter Mansfield truly deserved the Nobel Prize. However, a few others felt that Raymond Damadian's recognition of differing T1 values in cancerous tissues set the ball rolling in the direction of human organ imaging using NMR and provided the motivation for research, and hence he also deserved equal credit. The debate is unsettled to this day.
MRI was adapted for clinical use in the early 1980s. In fact, the first reports in radiologies pertaining to MRI were published in 1980. In 1984, George Westby, together with Michael Mosley and Richard Eman, introduced the field of diffusion imaging. In 1985, Denis Lebihan published the first diffusion-weighted image using a whole-body MRI system, showing that the intravoxel incoherent motion of water molecules can be utilized as a new contrast mechanism in MRI, particularly for the neurological applications. In 1990, Michael Mosley demonstrated the first successful clinical application of dMRI in imaging the ADC of the brain following ischemic strokes. In 1994, Peter Busser, together with Denis Lebihan, introduced the diffusion tensor imaging, which provided a means to quantify the isotropic and anisotropic components of the diffusion tensor and is the basis for dMRI fiber mapping and tractography.
Currently, MRI is an actively advancing field as seen by the numerous developments mentioned. The major problems MRI faces are the relatively long acquisition times and the claustrophobic and noisy environment experienced by the patient. Researchers are actively involved in coming up with solutions for these. Multiple techniques have been developed to accelerate the scans and reduce the acquisition times. Quantitative MRI is a relatively new field showing a lot of promise. It involves mapping the relaxation properties of tissues like T1, T2, proton density, etc. These properties could serve as biomarkers for early detection of diseases. This is where the project BQ-Minded also comes into the picture. In BQ-Minded, ESRs are working on accelerating MR acquisition, thus reducing the scan time. ESRs are also working on developing new biomarkers of brain disease using quantitative MRI and also on improving the accuracy and resolution of the existing techniques. With more robust quantitative MRI protocols, the day is not far when quantitative MRI is used routinely in the clinic for early detection of diseases and prognosis. To conclude, the beautiful imaging technique of MRI is a culmination of the effort of many researchers with contributions from the field of physics, chemistry, and mathematics. The technique has, since its invention, impacted the lives of millions of patients worldwide and continues to do so every day. The technique is still actively evolving, opening a myriad of different possibilities of probing the organs non-invasively. The future looks very bright, and the excitement is palpable among scientists working in the field of MRI.
Thank you for listening to our educational podcast. Bye bye!
Bye-bye!